Hey everybody, we're going to start chapter 6 now. And chapter 6 has to do with ratios, rates, and proportions. So let's see what those things are. Let's start with ratios. First, a ratio is a comparison of two items, specifically two items with the same units. They always have the word two between them. So the ratio of $7 to $3, notice they're both dollars, right? You can either write it with the word 2 between it, 723, or with a colon, which is red 2, or with a fraction bar, right? When we know we're specifically talking about ratios, we even read that 723. Okay, what we're going to do is mainly we're going to write them as fraction bars because they're simpler to deal with. Okay, so order is important. The quantity mentioned first is the numerator, and the quantity mentioned second is the denominator. For example, if you want to write the ratio 5 to 12, it's 5 over 12, right? 5 to 12. Okay, so now we are asked to write a ratio as a fraction. Ancestors of the Pueblo Indians built multi-story apartment towns in New Mexico about 1,100 years ago. A room might measure 14 feet long, 11 feet wide, and 15 feet high. Write the ratio of the length of a room to its width. Okay, so length, actually let's even do this just to, all right. So here we've got length, and here we've got width. It doesn't matter, they also told us how high they were, right? Which is interesting, right? That's a really tall, a really tall room. Okay, so what we're interested in is that length to width. So length comes first, and it's 14 feet over 11 feet. Now notice, because both of these are feet, I don't have to write the units. So the final simplified version, and also make sure that your fraction is completely simplified, but 14/11 doesn't simplify any further. So the ratio of the length of a room to its width is 14 to 11. Yeah, it's pretty simple. It's pretty basic. Okay. Write the ratio of 60 days to 20 days, okay, as a fraction in lowest terms. So the 2 is in, the 60 comes first, that goes on top, 60 to 20. And technically, they both have days, but they would cancel out, so I don't have to write the units when I'm writing a ratio only. Now, since it's in fraction form, this is why we prefer writing it in fraction form instead of the colon or with the word 2 between it. It's because it's easier to simplify. So now both of these are divisible by 3. Now here's something interesting and important about ratios. If this was a simple fraction without a ratio, I would just write that as 3. Right? But a ratio needs two, we're comparing two items. So I need to see both numbers. I'm going to leave that when it's a ratio as 3 to 1. Right? If I was just simplifying a fraction for some other type of problem, I would leave that as 3 because that's a simpler version. But now I need to see the comparison of two different items for a ratio. Okay, write the ratio of 50 ounces of medicine to 120 ounces of medicine as a fraction in lowest terms. So the 50 is before the 2. So 50 over 120, and the ounces is going to cancel out. Simplify the fraction, 5 to 12. Okay, The price of a Sunday newspaper increased from $1.50 to $1.75. Find the ratio of the increase in price. Be careful. It doesn't say find the ratio of the beginning price to the original price. Find the ratio of the increase in price. So first I have to find out how much did this price increase. If it went from $1.50 to $1.75, it increased by $0.25, right? Okay, so the increase in price to the original price. They're both dollars, so the dollar sign gets to divide out. But now I need to simplify this. I don't know if we've mentioned this before, but you can't mix fractions and decimals, right? I can't mix fractions inside decimals. So the easiest thing to do, remember when you're dividing decimals, you move that decimal in the divisor all the way to the end of the number. Okay, so what I'm going to do if I have decimals mixed in fractions is I am going to find whichever one has the most digits behind the decimal. Okay, these are the same, but whichever one had the most, and I would move my decimal that many times until it gets to the end of the number. And then with the other one, I would move it the same amount of times. Okay, that's how we're going to get rid of fraction or decimals inside fractions. Let me make an aside over here. Let's say that we had 8 over 1.34. Okay, this one has the bigger number of decimals, so I would move it 2, but that means then I've got to move this over 2. So that would be 800 over 134. Okay. All right, now we got to go back and simplify this, right? Both of these are divisible by 25, but if I didn't catch that, remember, I'm going to go back just for emphasis sake for those of us that are still maybe struggling a little bit. And I know 25 is 5 times 5. If I need to come down here and do this, right, 10 times 15, and this is 2 times 5. And 3 times 5 to get all of my factors, then that's fine, whatever we need to do, right? The 5s will divide out here and here. That'll leave nothing but a 1 in the numerator and a 2 times 3 in the denominator. Now hopefully most of us said, oh, these are both divisible by 25. And so 25 divided by 25 is 1. And easy when you're dividing by 25, think of quarters. How many quarters is in $1.50? Well, there's 4 in a dollar, and then 2 more in 50 cents, so 6. Okay, so whatever you need to do, whatever makes it easiest for you. Okay, write the ratio of 2 days to 2 1/4 days as the ratio of 2 whole numbers. So 2, 2, 2 1/4. Now remember, this is a complex fraction. We can't have complex fractions. So to simplify that, first thing I need to do, right, is make this an improper fraction. 4 times 2 is 8, plus 1 is 9. And then this is simply 2 divided by 9/4. Now remember, when I'm doing any operation with fractions, I want them all to look like fractions. So to do a division, it's copy, dot, flip. And then, since nothing will simplify, numerator to denominator, you multiply straight across. Okay, so just set up your ratio and then perform the operations like we've practiced. Okay, write the ratio of 3 1/4 to 1 1/2. So 3 1/4, 2, 1 1/2, which is 4 times 3 is 12 plus 1, 13 fours, 2. 2 times 1 is 2 plus 1 is 3 halves. So this is simply 13 fours divided by 3 halves. When you divide fractions, you copy, dot, flip. Now anything that's the same, that has a common factor in the numerator and denominator, you can divide out. 2 divided by 2 is 1. 4 divided by 2 is 2. And then multiply straight across. 13 times 1 and 2 times 3. Okay, now they're going to start talking about rates, but I feel like they left out something. So I'm going to do one more problem of ratios. Your units have to be the same. So if you had a problem and it said write the ratio 2 feet to let's say 36 inches, right? This isn't 2 to 36. These have to be the same. So I need to either change the feet to inches, and if I know that there's 12 inches in every foot, 12 times 2, this would be 24 inches to 36 inches. Or I could change this one to feet. So 36 inches is 3 feet, 2 feet to 3 feet. Either way, you'd get the same answer, but I have to have the same units. Okay, they've got to be the same so they can divide out. So here, this would be 2 to 3, right? And the feet would divide out. Or here, we'd have 24 to 36, which reduces to 2 to 3. We divide both of those by 12. Notice these are the same, but it is not 2 to 36 or 1 to 18, right? You got to have those units the same, so don't forget that. Okay, now they're going to talk about rates. So that was ratios. That's how to write a ratio. Now how to talk about rates. A rate is a comparison of measurements with different types of units, right? If you hike 18 miles in 4 hours, that's a rate. So it's still use the fraction form, but the units do not divide out because they're different. Okay, I'm still going to simplify the numerals, but I must leave this miles in hours. So this is you walk 9 miles in 2 hours. Okay, so in rates, instead of the word to between them, you might see these words: in, for, on, per, from, right? Your car gets 25 miles per gallon. You're driving 50 miles per hour. Those are rates. Okay, so write each rate as a fraction. Okay, notice this one has for, in, on. So 5 gallons of chemicals for $60. And the gallons and the dollars has to stay. But now this 5 and this 60, I can simplify that. They're both divisible by 5. So that's 1 gallon for 60 divided by 5 is 12. That's some expensive chemical, right? For $12. Okay, $1,500 wages in 10 weeks. $1,500 in 10 weeks. Okay, the dollars and weeks has to stay. It's wrong if they're not there. But the numerals, I need to simplify. Okay, so they're both divisible by 10. So $150, and you can put in 1 week, right? Or it would even be okay to put it like this, $150 per week. Okay, we're about to talk about these. These are called unit rates, as a matter of fact. And a lot of times we want it in a unit rate. Okay, 2,225 miles on 75 gallons. So 2,225 miles on 75 gallons. Okay, so once again, if we recognize these are both divisible by 25, we could do that math. If you need help with simplifying, remember to go back to your basics. Excuse me. Okay, now once again, if a number ends in a 5, maybe I know that it's divisible by 5. If you have to come over here and see what that is, that's fine. 5 goes into 20 4 times. 4 times 5 is 20. Subtract and bring down. 5 goes into 22 4 times. 4 times 5 is 20. Subtract and bring down. 5 goes into 25 5 times. 5 times 5 is 25. So it ended. So I've got 445 over here. Well, that's divisible by 5 again. And if I have to see what is it, 445 divided by 5. 5 goes into 44 8 times. 8 times 5 is 40. Subtract and bring down. 5 goes into 45 9 times. 9 times 5 is 45. So this is an 89. Okay, so now I'm wondering, whoops, sorry, didn't mean to circle that. Now I'm wondering, what about the 89? Is there anything that I can divide into 89? Well, 2 doesn't go into it because it's not even. Right? 3 doesn't divide into it. 4 doesn't. 5 doesn't. 6 doesn't. 7, 8, 9, 10. Turns out this is a prime number also. But I just have to check and see if anything will divide into it. So on the top we have 5 times 5 times 89. Don't forget your miles. And on the bottom, you can go up if you need to do 75 the same way. I know that it's 5 times 5 times 3. Now the 5s will divide out, and you're left with 89 miles for 3 gallons. Okay, writing rates. The units do not divide out. Okay, now they're going to talk about unit rates, which we just talked about. It tells us how much you pay for one item or one unit. In other words, $3.25 per 1 gallon, $47 for 1 shirt, $2.98 for 1 pound. So to do a unit rate, okay, first let's do the rate. Okay, 337.5 miles on 13.5 gallons. Now I need this number to be 1. When you divide anything by itself, it's 1. So I have to do the same thing to the numerator and the denominator of a fraction, and I'm going to divide them both by 13.5. 13.5. Now that makes this 1. I already know that, right? 13.5 divided by 13.5 is 1. But I've got to come down here and see, well, what is 337.5 divided by 13.5. Okay, if I'm dividing by a decimal, the decimal comes to the end of your divisor, and then I move this one the exact same amount, and that tells me that's where my decimal goes in my answer. Okay, if this bit bothers me now, I can get rid of it because I already have my decimal placed as long as I keep my columns straight. So 135 going into 337 because it won't go into 3 or 33. So I'm just thinking about what about 13 into 33? Well, that'll go 2 times. So I'm going to try that up here for the whole thing into 337. So 2 times 135 is 270. Go over to the side if you have to figure out what it is. That's fine. 7 minus 0. Okay, I'm going to have to borrow here. So 13 minus 7. Subtract and bring down. Excuse me. How many times does 13 go into 67? 5. So let's try 5 for the whole thing. I'll be 1 away at most. 5 times 5 is 25. 5 times 3 is 15. 16, 17, 5. Oh, yay. Yay. I don't have to bring anything else down because I'm at the end of my problem. So I know that this is 25 miles now. And this is fine if you want to write it like that, but on unit rates, we also have the option of doing it like this, miles per gallon. Okay. Okay. The local store charges the following prices for pancake syrup. Find the best buy. Whenever you ask a question like this, what do you think you need to know? Do I get a 36-ounce bottle, a 24-ounce bottle, a 12-ounce bottle? Yeah, I need to know how much it is per ounce, how much each one is per ounce. Okay? We used to could just judge that the biggest one was the best value. You know, you get a better deal if you buy in bulk. Not anymore. Products trick us and they make us buy more and pay more, right? So let's do per ounce. I don't have much room here, so I'll try to squeeze it in. So let's do the first one. This one is $1.28 for 12 ounces, right? I want to know how much dollars per ounce is. That tells me how to set up that ratio. So I'm going to divide both of these by 12 because on the bottom I want that to be 1 ounce. Okay, so I'm going to take that 128 and divide it by 12. Since 12 is a whole number, I don't need to move the decimal. It means it's going to go right there. 12 goes into 12 one time. Okay. Bring down. 12 doesn't go into 8, so I need to add a 0, and 12 goes into 80. Let's see, 6 times. 6 times 12 is 72. So subtract and bring down. Now, how far do I need to go? We're going to do these in pennies, so I need 3 decimal points. I'm going to round to the nearest cent, right? Since this is what I'm rounding to, that number is bigger than 5, or bigger, I'm going to change that to 17 cents. So now I've got $0.17, right? Or 17 cents an ounce. Let's do the next one, okay? Let's do the biggest one over here, and then I'll try to do that one in the middle. So the biggest one, okay? So I got $2.73 for 36 ounces. So I need to divide both of these by 36. I know that's going to be 1 ounce. when I divide it by 36, and then 273, just so that everything's not too jumbled together, right? You can separate it by color. 273 divided by 36. Okay, so my decimal is going right there. 36 does not go into 27, so I have to tell the problem that I've got to have a digit above every number after the decimal, right? So then I'm thinking about 36 into 273. I don't know. What about 3 into 27? Well, that's 9, so let's try 9. 9 times 6 is 54. 9 times 3 is 27. Plus 5 is more than that, so it must be 8. Okay, I'll be at 1 away at most if I use that method. 8 times 6 is 48. 8 times 3 is 24 plus 4. Oh, let me double check that. 8 times 6 is 48. 24. My goodness. I just told you a fable. All right. Let's make it 99% of the time then. Then I'll have to quit saying always. So let's go down one more. I should have said should, not always. I should be within 1. 7 times 6 is 42. 7 times 3 is 21 plus that 4. And if you have to go over to the side and do it, that's fine. That's fine. Okay. 3 minus 2 is 1. 7 minus 5 is 2. And I've got to bring down. Okay. Now, 3 goes into 21 7 times, but because there's going to be this 7 times 6, I know that's too much. Let's try 6. 6 times 6 is 36. 6 times 3 is 18. 21. Okay, 1 off again, but that's okay. That will make this a 5 now. And really, that's all I need to know. 5 times 6 is 30. 5 times 3 is 15. Plus 3 is 18. So when I subtract, we get 30. Okay, but now I can round. Because I'm going to round to the cent. This number is a 5, so that's going to go up to 0.08. So 0.08. So far that's way cheaper than 17 cents an ounce, 8 cents an ounce. Let's try this one. It tells me that, let's see, I have to pay $1.81 for 24 ounces. So I'm going to divide both of them by 24 so that this becomes 1 ounce. I just have to go over here and see what is, I hope we have room, for 181 divided by 24. Okay, 2 goes into 18 9 times, although I can tell that because this is a 1 and that's a little large. Let's try 8. 8 times, not there, not there, not there. Okay, it doesn't go into 18. We already said that, we just didn't put our 0 up here. So now we're trying 8 for the whole 181. 8 times 4 is 32. 8 times 2 is 16, 19. Even that one was a little large. Okay, so we're going to try 7. 7 times 4 is 28. 7 times 2 is 14, plus the 2 is 168. Let's subtract. 11 minus 8 is 3. Okay, and bring down. 2 goes into 13, let's say 6 times, right? 6 times. So 6 times 4 is 24. 6 times 2 is 12. 13, 14. That's a little too big, so we'll do 5. 5 times 4 is 20. 5 times 2 is 10, 11, 12. So that leaves a 10. Okay, look at this dilemma. So far, these are exactly the same. And it asked me which one is the best buy. How do you think I'm going to find out which one is the best buy? Yes, hopefully you said, I need another digit, right? These are going to round to the same amount of whole cents, but if I need one that's best, I got to keep going until I get a different digit so that I can tell. So let's bring down. Now I know 24 goes into 100 4 times, and that's 96. So that leaves a 4. Let's see what we get over here had we continued. So far, 0.0754. Let's see where we were. We had 30. Okay, so that goes 8 times. Okay, 8 times 6 is 48. Now I know I'm cutting out some of the shortcuts, but figure it out. 8 times 3 is 24, 28. So that is right. Okay, so now I had to go back, go that extra digit. Even though it didn't ask me what they were, it said which one is the best buy. So I know that this one is actually the best buy. These were very close to the same price though. But finding that unit price is how we determine. Okay, well, duh. Okay, so that was ratios and rates. Ratios must have the same units and they have the word to in between them. Rates have different units and so the units must stay. Okay, a proportion is when you have two ratios or two rates that are equivalent. Okay, so for example, like this, they're saying $20 every 4 hours is the same as $40 every 8 hours. So this is a proportion. You just figure out whatever each individual ratio or rate was and you set them equal. Okay, so they're saying this is how you read it. $20 is to 4 hours as $40 is to 8 hours. Okay. All right, so write each proportion now. 6 feet is to 11 feet as 18 feet is to 33 feet. Notice this uses the word to, so these are two ratios. So I really don't need those units of feet. Okay, so I can say 6 to 11 is as 18 to 33. And that's our proportion. Okay, so we're still using the word to here, but what I notice is they have different units. So these are actually rates. I gotta keep those units. So I'm going to say $9 is to 6 liters as $3 is to 2 liters. Okay, now notice something about this. If I reduce this fraction, if I divided both of these by 3, I'd have 6 over 11, right? If I divided both of these by 3, I'd have 3 over 2. Yes, duh, they're equal. They're equivalent fractions. That's what a proportion is. They're saying they're equivalent fractions. Okay, so determine whether the proportion is true or false by reducing each fraction. 5/9 doesn't simplify any further, but 18/27, right? 18/27, each one of those is divisible by 9. 18 divided by 9 is 2, and 27 divided by 9 is 3. So the question is then, is 5/9 equal to 2/3 No. No, it's not. This says by reducing each ratio to lowest terms. It might have been easier for us to think about. Let's see if we can make them have the same denominator. I notice that this has a 9, so if I just divide this by 3, 27 divided by 9 is 3, and 18 divided by 9, no, that's what we did. Sorry. I mean, because I'm trying to leave that 9, so I want to do 27 divided by 3 is 9, 18 divided by 3 is 6, and then we could compare 5/9 and 6/9, and it might be a little more obvious to us, although if they're reduced in lowest terms and they're not exactly the same, they're not equal, right? But sometimes this might be a little more helpful. Oh no, 5/9 is not as much as 6/9. So whatever makes it easiest for you. Okay. So we can use cross products to determine whether a proportion is true or not. Okay. Notice right here, they said 5 times 4 and 2 times 10. Now, I'm not really, okay, and both of them are 20, that's fine. If the cross products are unequal, the proportion is false. Okay, they're writing them on the side. I'm going to write them above, but I guess it doesn't matter. Okay, so here we go. Use cross products to determine. And technically in this one, I could do either method because, let's just show to start with, because I could reduce this fraction, right? So that I have a 5 in that denominator. 20 divided by 4 is 5. And 12 divided by 4 is 3. And I see it's true. So I don't just have to use one method. But sometimes if this would have been 21, I couldn't have made them the same denominator, so it would have been hard to tell. So another method is I could do my cross product, right? So 5 times 12 is 60, and 20 times 3 is 60. Okay? And if those numbers are the same, then yes, they're equal. Okay, in this case, this might have been the easier method. Might have been, depending on how hard 5 times 12 is for us. Okay, but this one, notice, oh, I can't really, simplify that down without a lot of work. So I'm going to use my cross products to see if they're equal. So I have to do 3 1/3 times 9. Okay, well, let's come down here and do it. 3 1/3 times 9. If any of them look like fractions, I want them all to look like fractions. So 3 times 3 is 9 plus 1 is 10 over 3. All of them need to look like fractions. The 9 and the 3 are both divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So I wind up with 30 over 1. Okay, so 30. And then 16 times 2 1/3. 16 times 2 1/3 is 16 over 1 times 3 times 2 is 6, plus 1 is 7 over 3. Nothing will simplify here. So 16 times 7 is 112 over 3. Well, 112 is not divisible by 3. By the way, do we know a shortcut for telling us these things? If you add all the digits and they add to a number that's divisible by 3, your number is. The reason I knew right away this was not divisible by 3 is because 2 plus 1 is 3 plus 1 is 4, and 4 is not divisible by 3. Right? If I had this number, It is divisible by 3 because I'd have 2, 4, 5, 6. So that number is divisible by 3. All right, so I'm just going to leave this 112 thirds. But then when I say, well, what's bigger, 112 thirds or 30? I don't know. So I just told you another story. I'm not going to leave it 112 thirds. I'm going to see what that is. 3 goes into 11 3 times. 3 times 3 is 9. 3 goes into 22 7 times. 7 times 3 is 21. And it really doesn't matter what the decimal winds up being. This number is 37 plus, right? So false. False. Okay, if they're not equal, it's false. Okay, so we can use that method to actually solve a proportion, right? Find the cross products, show that they're equal. In other words, set up your equation and solve for the original product. That's not very good explanation. Let's just do an example. All right, if I'm solving for the value of x that makes these two ratios equal or makes this proportion true, then I'm going to use my cross products. And I'm going to say, oh, if that's got to be true, then 32 times x has to equal 16 times 20. 32 times x has to equal 16 times 20. Okay, so what some of us might do at this point is let's multiply this together. 32x, do any work you can do. So 16 times 2 is 32, 320. Divide both sides by 32, just using those steps of solving an equation. So x equals 320 divided by 32 is 10, and we solved it for x. Okay, so not too bad. They made those numbers nice. Now for some of us, for the most part, we're going to do this each step. But for some of us that are a little farther along, here's a nice option for us if we get numbers that are kind of large. Once I had this point, I might, instead of multiplying those numbers together, this was good because it was times like a multiple of 10, so it wasn't hard. But if I had hard numbers over here, I might go ahead and divide by that 32 and just keep my numbers smaller. And then simplify up here, you know, oh, I know that 32 is divisible by 4. And so is 20. Okay, now I also know that 16 is divisible by 8. And see, I wind up with 2 times 5 on the top. So that's nice to help keep our math easier. Okay, same thing. Got a proportion. So if I cross multiply, I know that 7x has to equal 12 times 15, right? 7x has to equal 12 times 15 if I want those things to be equal. So I could come over and find out what 15 times 12 is if we don't know. I believe it's 180. Okay, so that's 30 and that's 15. Yes, it's 180. Okay, so 7x equals 180. And then divide by 7. And we realize that 180 isn't divisible by 7, I don't think. Let me check just a minute. No. So or likewise, we could have said 7x equals 12 times 15. Okay, divide by 7. And when my numbers are small, I know that 12 and 7 don't simplify, and 15 and 7 don't simplify. So this didn't help me keep me from having to multiply 15 times 12, but it did make me realize that, oh, that's not a wasted step, and once I got it multiplied, I don't have to worry about whether that simplifies or not. If that doesn't quite make sense to you, forget this, right? Just stick with the basic. Here's what we do every single time. But if this makes sense, right, it's really handy. Okay, here we go again. So I've got 2 1/5 times 10, cross multiply, so I'm going to do the 6x first. So 6x has to equal, I might go over to the side and see, well, what is 2 1/5 times 10? That is 5 times 2 is 10, 11/5 times 10 over 1. So 5 divided by 5 is 1, 10 divided by 5 is 2. So that is equal to 11 times 2 and 1 times 1. So 6x equals 22. And now let's divide by 6. I really didn't get that shortcut option this time because I had to deal with that multiplication, right? It wouldn't help me to have written this 2 1/5 times 10 and then divide by 6. I couldn't do anything with that anyhow. Okay, so x equals, these are both divisible by 2, so 11/3. Okay, I don't know if there's any more or not. Let's see. Nope, that was it. Okay, ratios, rates, proportions. Okay, let me know if you need anything. Bye-bye.